Now that we have discussed about the different types of special cases of the quadrilateral, let's take the case of parallelogram and define its various mathematical properties connecting the parallelogram. A special case of a quadrilateral called parallelogram. Today's session is about properties of a parallelogram. Properties of parallelogram. One of the most important property is the property which connects the diagonal of a parallelogram. So let's see and revisit a parallelogram and its diagonal. We know that this is the shape of a parallelogram. A, B, C and D, in which opposite sides are parallel, is how we understand a parallelogram ABCD. Now the property which connects the parallelogram is with the diagonal. So imagine I connect the diagonal AC. Now here AC is the diagonal which connects the two alternate points. Now when we see clearly the parallelogram with AC being the diagonal, the significance of the diagonal is that this diagonal cuts the parallelogram into two triangles. So here I have diagonal AC cuts the parallelogram ABCD into triangles, the two parts being the shapes of triangles. The first part of the diagonal is triangle ADC, and the other part of the triangle of the other part of the parallelogram cut by the diagonal is ABC, triangle ABC. Therefore, I have two triangles as cut by the diagonal AC such that ABC is one triangle and ADC is the other triangle. The two triangles, triangle ADC and triangle ABC. So let's see the properties connecting these two triangles in a parallelogram. So here the property states that a diagonal cuts the parallelogram into two equal triangles, or if the diagonal cuts the parallelogram, then the two triangles formed are said to be congruent to each other. That is, the property is triangle ABC is congruent to triangle ADC. Is how we connect the property. When two triangles are formed by the diagonal, the two triangles are congruent always in a parallelogram. Let's take the other case. If suppose I have another diagonal which joins from D to B. Now again I have triangle also for diagonal BD. Out here I have two triangles ADB and BDC which are also congruent to each other. If I take the diagonal, the second diagonal, triangle ABD is also said to be congruent to triangle BDC. is how we understand the property of a parallelogram. A diagonal cutting the parallelogram cuts the parallelogram into two triangles, and the property says that for a parallelogram where the diagonal cuts the parallelogram into two triangles, the two triangles must be congruent to each other. This congruent to this and this congruent to this. There are two diagonals in a quadrilateral, diagonal 1 and diagonal 2. This diagonal makes these two triangles congruent. This diagonal makes these two triangles congruent, and this diagonal makes these two triangles congruent. The diagonal connects with congruency of triangles. Now let's see the property of a parallelogram which connects with the sides. Let's see the other property of a parallelogram. Connecting with its sides. So let's see the property which connects with sides. Parallelogram ABCD. Here is the parallelogram A, B, C and D. So clearly in a parallelogram we know that opposite sides are parallel. Now when the opposite sides are parallel, clearly I see that there is equal distance between the two parallel lines. But this equal distance is again cut short by two more parallel lines, where again there is an equal distance between these two parallel lines. So parallelogram is a closed region bounded between the pair of parallel lines. Therefore, it comes to an interesting geometrical property which arises out here. The pair of parallel lines makes a bounded region where the lengths are equal. The pair of parallel lines always makes the lines to be equal. So this side must be equal to this, and this side must be equal to this. That is, when the opposite pairs are parallel in a quadrilateral, their opposite sides are equal or also equal in a quadrilateral. Therefore, with this property, I come to a conclusion that the opposite sides AB is equal to DC and my AD equal to BC. Therefore, my opposite sides are equal. So here, the reason being that since opposite sides are parallel, therefore the opposite sides must be equal. Therefore, the property in a parallelogram is that learning outcome in this property is that opposite sides of a parallelogram are equal, is how I understand opposite sides of a parallelogram are always equal. Property number 2, opposite sides of a parallelogram are always equal. Now let's see the converse of the property which we have discussed in the previous session. Like for example, I have taken a parallelogram in which opposite sides are parallel, then that quadrilateral has its opposite sides equal. Now let's take a quadrilateral in which the pair of opposite sides are equal. Then will that be a parallelogram? So here it is converse of parallelogram. So let's see the converse as the properties of a parallelogram. The converse says if a pair of opposite sides of a quadrilateral are equal, then the quadrilateral must be a parallelogram. Then that quadrilateral must be a parallelogram, is how I understand the converse. That is, if I take the pair of opposite sides, I take the two lines of equal lengths and I take two pairs of equal lines and I form a closed figure, then that closed figure must be the shape of a parallelogram, is how the property defines. So the four lines, these two being of equal length and these two being of equal length, clearly I get a closed figure in which the opposite pairs being equal makes it indirectly to be parallel, is how we understand as the converse of the previous session. If two equal lengths are paired together to form a four-sided closed region, then mathematically we conclude that those pairs will obviously be parallel. So the parallelity derived from equal lengths is how the learning outcome comes out. Therefore, in this case, opposite pairs equal, opposite pairs equal implies opposite pairs parallel. So equality implies parallelity and parallelity implies equality. So opposite pairs equal implies opposite pairs parallel, hence a parallelogram. Is how we understand a quadrilateral reducing to a parallelogram, either the pair of sides being equal or the pair of lines being parallel. Parallelity implies equality and equality implies parallelity. If a pair of opposite sides of a quadrilateral are equal, then that quadrilateral must be a parallelogram. The converse of the previous session.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.